This presentation introduces the geotextile process for sludge dewatering in municipal, industrial, food processing, and agricultural applications. Sludge dewatering can present problems for all of these industries. Geotextile fabrics can be used to provide the operator an inexpensive and effective process to dispose of his solids. Geotextile fabrics are sewn into filter bags that are used to offer alternative tools for separating and dewatering waste-activated sludge, water backwash sludge, food processing sludge, industrial sludges, and confined space operation animal waste. The geotextile container bag process uses bags sewn to fit into a variety of containers, including front-load 2, 3, and 4-yard containers and 10, 20, and 30-yard roll-off containers. The geotextile bed bag process uses bags sewn into long tube-type shapes. The bags can be laid out on existing sand drying beds, or they can be placed on special concrete dewatering pads. Geotextile bags can be used to dewater wastewater lagoons. Sludge can be pumped from the lagoon with a dredge or a floating pumping raft. It can be pumped up to the bank and treated with a flocculant as it flows into the bag. Effluent flowing from the bag can be returned to the lagoon or diverted to another holding area. The geotextile container bag process can be used in those plants where the sludge is intended to be disposed of in a landfill. The bag is sewn in a bread box shape to fit into a variety of landfill containers. In this case, the container is a standard landfill roll-off container. It can be placed on an existing drying bed. Placing the roll-off on a drying bed typically requires concrete runners to support the weight of the roll-off. In many cases, the roll-off is staged on a concrete pad especially designed and poured to hold one or multiple roll-offs. Some type of drainage system is required to capture and return the clean effluent back to the plant. The components of the Blue River Technologies container bag system includes a polymer makedown unit that is used to produce the flocculant solution, a flocculator and fill tube package that is used to mix the polymer solution with the sludge, the container bag, and some type of drainage space under the bag. Drainage netting is used to keep the bag from sealing off on the smooth sides of the container. First, prep the container with some kind of airspace under the bag. It can be as simple as wooden pallets under the bag, or corrugated 4-inch slotted drain pipe can be used to provide a space for the effluent to flow rapidly out of the container. Drainage netting is installed over the airspace and up the sidewalls of the container. The bag is then rolled out inside the container, starting at the front of the roll-off. The bag fills the entire bottom of the roll-off. A fill tube is inserted into the port of the bag. The port is located on the top dead center of the bag. The port is a fabric port that is wrapped around the fill tube or the fill hose. Then, 3 heavy-duty tie wraps are used to secure the tube in the port. The fill tube can be supported with a 2x6 or 2x8 laid across the top of the roll-off. Here the bag is installed in the roll-off and is ready to be filled with treated sludge. Locate the flocculant mixer in a convenient place near the roll-off. The sludge discharge line is hooked up to the inlet of the mixer, and the discharge of the mixer hooked up to the fill tube with cam-lock quick disconnect fittings. As sludge is pumped through the flocculator, it is mixed with polymer solution. The solids separate from the water, and the clear water flows out of the pores of the filter bag. Clean effluent flows quickly out of the roll-off and is collected by the drainage system. Typically, the water drains from the bag at a rate of from 50% to 75% of the pumping rate. That depends on the percent solids of the sludge. The effluent that flows from the bag will be clear, with 99% of the solids retained in the bag. This bag is full and the pump needs to be shut down to let the bag dewater. The bag will drop down as the water runs from the bag and it then can be pumped up again. The bag will be pumped several times before it will be full of dewatered solids. When the bag is full of solids, it will hold around 15 tons of dewatered material. The roll-off is picked up, the bag is dumped, and the roll-off returned to the plant to have a new bag installed and the process repeated. With a container bag process and a municipal waste application, you will have solids of approximately 16%, easily passing the landfill paint filter test. This is a standard flocculator with a 4-inch inlet and outlet connection. This flocculator includes a polymer solution injection point, a steel stand with wheels to allow it to be moved in and out as needed. At the end of the flocculator, a 2-inch valve is used to sample the sludge to ensure that a good flock is being produced. Many different configurations are available for the flocculator. Some dewatering systems use a permanent hard pipe installation for the flocculator. The polymer solution is made down with a polymer mixer. Clean filtered water is mixed with the neat polymer to produce a solution from 1/4 to 1/2% in solution strength. The polymer solution is injected into the sludge stream just ahead of the flocculator. The flocculator will mix the solution with the sludge, causing the fine particle solids to come together into a tight mass. The water is squeezed out and becomes free water that will flow through the pores of the filter bag without blinding the opening. Many new plants are being designed with multiple roll-off dewatering pads and piping systems that save steps for the operator. This plant has a 2 roll-off installation with overhead loading for the bags. Chain-operated valves on the horizontal legs allow the operator to switch filling between the bags. This setup has room for 3 roll-offs. At this plant, the flocculator was installed in an underground vault located just outside the containment area. Geotextile dewatering is an all-weather system. Sludge freezing in the bag will not shut down the system. Sludge freezing in the piping system or the drainage system will, however, so care and thought should be used when designing the system for cold weather zones. This plant sets 2 roll-offs on existing drying beds. They have eliminated manual handling of their dewatered sludge. Blue River Technologies offers container bags in a variety of sizes and configurations. Roll-off container bags are available from stock in 10-yard and 20 and 30-yard configurations. Other sizes are available on special order. Front load and forklift load container bags are available for 2-yard, 3-yard, and 4-yard sizes. Note the drainage platform that this container sits on. This polymer makedown and flocculator setup is completely self-contained. All exterior lines are heat traced where needed, and the polymer enclosure is heated. The Blue River Technologies container bag system is a low-cost and very efficient method for dewatering and disposing of many different types of solids bearing liquids. The geotextile bed bag system utilizes larger bags, commonly placed on existing drying beds or on a specially prepared concrete dewatering pad. Many wastewater treatment plants use drying beds to dewater their sludge. These beds have limited capacity and can take a very long time to dry in wet weather or in the winter months. Utilizing geotextile bags on the beds will greatly increase the capacity of the bed and make the bed an all-weather tool. The bags are laid out over the bed and a drainage mat placed underneath. The bags are repeatedly pumped up until they are full of dewatered solids. In this setup, a gauge line is installed over the bag to tell the operator when he has pumped the bag to its maximum design height limit. The fill tube of the bag includes a slide valve to allow the operator to shut off the tube to remove the fill hose and move it to a different bag in the system. In this setup, the plant has installed permanent fill points, each with its own valve to allow switching back and forth between the bag ports. In a system like this, care must be taken to make sure the manifold can be drained out after use to prevent damage in freezing weather. When a bag is full, the operator will cut it open and load out the solids for disposal. The bed bags are very useful in those plants where solids can be land applied. The cost savings of applying the material as a solid as opposed to hauling water to the fields is substantial. In addition, the extra capacity of the bed now makes it easier to apply the solids when the growing season dictates. Concrete dewatering pads can be designed and constructed to offer the operator many advantages over simply laying out the bags on drying beds. The pads make loading out the solids much easier and less time consuming. This bunker-style dewatering pad will accommodate a 45-foot circumference by 100-foot long dewatering bag. The geotextile bag process can be used to remove solids from lagoon systems. Both the container bag system and the bed bag system can be used. A mini dredge can be used to pump sludge from the lagoon up to the bag area. This dredge is a cutter head style electric dredge and will pump up to 300 gallons per minute. Small hydraulic or electric pumping rafts can also be used to pump to the bags, especially in those lagoons where the solids are suspended. It is important that the bag staging area be flat and well prepared. The bag must be laid out on a surface with no more than 1 or 2 degree slope. In most cases, a plastic sheeting or other barrier must be put down to place the bag on to prevent ground contamination with the effluent draining from the bag. Drainage netting can then be put under the bag to isolate the bag from the plastic sheeting. Sludge is pumped from the lagoon up to the bag staging area. The flocculant is mixed with the sludge just prior to it running through the flocculator and into the bag. In this case, the polymer mixer and flocculator are set up in a heated utility trailer. The bag is repeatedly pumped up and allowed to dewater until it's full. The effluent that flows from the bag is either gravity drained back into the lagoon or pumped to another holding area. This paper mill lagoon rapidly fills up with residue that must be removed on a biannual basis. In this case, a small hydraulic pumping raft is used to pump the sludge up to the bag area. The bag staging area is lined with plastic sheeting, drainage netting is laid down, and the bags placed over the netting. The bag staging area will hold 4 45-foot by 100-foot geotextile dewatering bags. At one end of the staging area, a trench is dug to hold effluent as it drains from the bags. A gasoline-powered pump is used to pump the effluent to a holding lagoon. A tank on the bank is used to hold the sludge as it is pumped from the lagoon. The tank is agitated to keep the solids suspended. A gasoline pump is used to transfer the sludge from the holding tank over to the flocculator located near the geotextile dewatering bags. The bags are repeatedly pumped up and allowed to dewater until they are full. The bags are allowed to dry, and then the solids are loaded out and taken to a landfill for disposal. The 45 by 100 foot dewatering bag will hold nearly 300 cubic yards of dewatered solids. For smaller projects, straw bales make a very efficient and effective effluent collection system. The plastic sheeting and straw bales form a basin to collect the effluent and divert it to a sump for disposal. The effluent flowing from the bags is collected and diverted to the sump where it is pumped back into the lagoon. The bag is allowed to dewater and dry for a couple of weeks to several months if the plant has the space and the time to wait. After cutting the bag open, the solids can be loaded out, land applied, composted, or removed to a landfill. This bag was opened after only 1 week of dewatering. The geotextile dewatering bag process is a proven option for removing solids from a lagoon or polishing pond. The flocculation process is the single most important part of the geotextile dewatering process. You must have the correct flocculant, and it must be properly applied in order for the bag process to work properly. Here we see on the left the sludge as it is pumped from a digester. In the center jar, a flock is formed and the water and the solids are properly separated. And on the right, the effluent that will flow from the bag in a well-designed system. Proper chemical mixing and injecting will produce a well-formed and tight flock that will give you excellent results with the geotextile dewatering process. Proper flocculation will produce crystal clear effluent and a much drier cake than a system with a poor mixing process or the wrong chemical or dosage. You can visually see in these examples a cake formed with poor chemical application on the left, only a fair mix on the right, and in the center a good cake formed with proper chemical selection and application. On the left you can see the cake releases from the fabric very cleanly. On the right, you have a poor release as a result of improper dosage of the chemical. Compare the amount of fines left unflocked in the picture on the left and the very good tight formed flock in the right picture. Spending the time to properly select, mix, and inject the chemical will save you money in both the number of bags you use and also a drier cake to dispose of at the end of the process. The Blue River Technologies patented dewatering tower is the third option for geotextile dewatering. The bag is suspended in a vertical tower. At the bottom of the tower, 2 hydraulic actuated doors are used to close and seal off the bottom of the bag. The tower is filled from the top, and as in all other processes, a flocculant is used to separate the solids from the water. The water releases from the bag and leaves the solids in the tower. The natural force of gravity and the vertical tower combine to increase the dewatering characteristics of the geotextile dewatering bag. Once the tower is full, it is allowed to drain overnight. In most cases, the tower is dumped the next morning and another batch is run through the bag. In some cases, multiple batches can be processed in a 24-hour period. When the doors are open, the solids fall straight down into a roll-off, a slinger, or directly on the ground to be pushed back for storage. In most cases, with waste-activated wastewater sludge, up to 20,000 gallons per day can be processed with the Blue River Technologies dewatering tower. The cake produced with the tower will be several points drier than the container bag or the bed bag process can deliver. With the application of the proper flocculant, belt press quality cake can be produced at much less capital or operating expense. The tower allows the geotextile dewatering process to be applied with reduced expenses. The bag is used over and over again, greatly reducing the cost of the process to the plant. Proper planning and implementation of a geotextile dewatering system will reduce the cost of sludge removal and make the task a lot easier. That will put a smile on everyone's face. Thank you for your attention. If you have any questions or require more information, contact us at Blue River Technologies. We will be happy to help.